He was a patent clerk who completely reimagined the cosmos, a pacifist who helped kickstart the atomic age, and yeah, probably the most famous scientist in history. And his ideas, they are still shaping your world right now as we speak. So let's dive into the incredible story and legacy of Albert Einstein. To really get Einstein, you've got to understand this one quote. See, he wasn't just some super genius with a brain built for math. No, he was driven by this relentless, almost childlike curiosity. It was this deep, fundamental need to question everything that let him see the universe in a way that nobody had ever even imagined before. So, how does a guy like that go from being a total unknown to a global icon? Well, let me tell you, it was not a straight line. I mean, he was brilliant at physics and math from a young age for sure, but after he graduated, he actually struggled for almost 2 years just to find a teaching job. And what's really incredible is that this job, looking over patent applications for inventions, this seemingly boring gig, turned out to be the best thing that could have happened to him. It gave him a steady paycheck, sure, but way more importantly, it gave him the time and the mental space to just sit at his desk and ponder the biggest questions in the universe. And all that thinking, man, it led to 1905, a year that historians now call his annus mirabilis, his miracle year. While he was still working as that patent clerk, he published 4 papers that didn't just add to the field of physics. They completely tore it down and rebuilt it from scratch. Okay, let's just pause and appreciate the sheer scale of this. In one single year, this guy laid the groundwork for quantum theory by figuring out that light comes in little energy packets he called quanta. He mathematically proved that atoms were real by explaining why dust motes jiggle randomly in water. Then he completely upended our understanding of reality with special relativity, showing that space and time aren't fixed. And as a little cherry on top, he gave us the most famous equation in all of science, E equal mc squared. Just wow. But he wasn't done, not even close. For 200 years, Isaac Newton's ideas about gravity were law. But there was this one little thing that just kept bugging Einstein, a question that Newton's physics couldn't quite answer. And that question would lead to his absolute masterpiece. This was the huge conceptual leap. He challenged the very idea of gravity being some mysterious, invisible force that reaches out across empty space. Instead, he suggested something way more bizarre and beautiful. What if gravity is just the shape of the universe itself? So his general theory of relativity describes gravity as a curve, a warp in the very fabric of space-time. Think of it like this. Imagine spacetime is a giant trampoline. If you put a heavy bowling ball in the middle, it creates a dip, a curve. Now, if you roll a marble nearby, it doesn't get pulled by the bowling ball. It just follows the curve that the ball created. It's this elegant dance. Matter tells spacetime how to curve, and that curve tells matter how to move. But a theory is just a theory until you can prove it, right? Well, in 1919, an astronomer named Arthur Eddington did just that. During a solar eclipse, he saw that the light from distant stars actually bent as it passed by the sun, exactly like Einstein's equations said it would. The news exploded. And just like that, the quiet patent clerk from Bern became the most famous scientist on Earth. But here's where the story gets really interesting. Even as he became this global celebrity for relativity, a whole new revolution was kicking off in physics, one that he helped start but could never fully get on board with. Quantum mechanics. This is maybe his most famous non-physics quote, and it gets right to the heart of his problem with quantum theory. Remember his work on the photoelectric effect? That introduced the idea of the quantum, but he just couldn't accept where the next generation of physicists, folks like Niels Bohr and Werner Heisenberg, took that idea. See, quantum mechanics said that at the tiniest, most fundamental level, reality is all about probability and chance. You couldn't know a particle's exact location and its exact momentum at the same time. For Einstein, who believed in a clockwork universe that followed predictable rules, this was just unacceptable. He famously argued with Niels Bohr for decades, insisting a theory had to be incomplete. But Einstein's life wasn't just about these deep theoretical debates. The real world, with all its messy politics, came crashing in, forcing him to become not just a scientist, but a conscience for the entire world. As a prominent Jewish intellectual in Germany, he was an obvious target for the Nazis. He had to flee in 1933 and eventually made his way to the United States. And though he was a committed pacifist his whole life, he made the agonizing decision in 1939 to sign that famous letter to President Roosevelt. He was terrified the Nazis might build an atomic bomb first. And later, as an American citizen, he became a powerful, outspoken voice for civil rights. This quote, man, it just reveals the immense burden he carried. He didn't work on the Manhattan Project directly, but he knew his equation, E=mc², was the scientific key that unlocked it. The unbelievable destruction at Hiroshima and Nagasaki haunted him for the rest of his days. So it's been over 100 years since his miracle year, but Einstein's revolution is far from over. In fact, you're living inside of it every single day, probably without even realizing it. That GPS in your phone, it literally has to account for the time-bending effects of both special and general relativity just to tell you where to turn. Lasers, fiber optics, we have them because of his early work on quantum theory. Nuclear power is a direct application of E=mc². And our entire modern picture of the cosmos, from the Big Bang to black holes, is built on the foundation he laid.
But even with all these monumental achievements, he never felt like his work was truly done. He spent the last 30 years of his life searching for what he called a unified field theory. He was chasing a single, elegant set of equations that could describe all the forces of nature in one beautiful package.
He never found it. But that search, that quest for a theory of everything, is still the absolute holy grail for physicists today. It's the ultimate dream, and it all goes back to his lifelong belief that underneath all the messiness and complexity, the universe is simple, it's beautiful, and we can understand it. The questioning he started, well, it never ever stops.